You know those massive industrial plants that, let's face it, kind of power our entire world? Well, inside them, it's not just pipes and machinery. There's this invisible guardian, this silent network that's really the last line of defense against a total disaster. So today, we're going to pull back the curtain on that very guardian, the fire and gas safety system.
Okay, let's get one thing straight right from the get-go. A fire and gas system, it is not like your smoke detector at home that goes off when you burn the toast. No way. When this thing activates, it's a giant red flag. It means that multiple other safety layers, things like process controls, even the operators themselves, have already failed. The incident isn't about to happen. It's happening right now. This system is the absolute last automated backstop.
So you might be asking, what makes this last line of defense so incredibly important? Well, it all boils down to a really simple but really dangerous recipe. And the scary part is, every single one of these facilities has all the ingredients just sitting there waiting.
It's something called the fire triangle. You probably remember this from way back in science class, right? You need three things: fuel, oxygen, and an ignition source, like a spark. Well, an industrial plant is basically the perfect storm for this. You've got tons and tons of fuel, all the oxygen you could ever need just from the air, and literally countless things that could create a spark. The whole job of the system is to catch a problem before those three things have a chance to meet.
And here's the really terrifying part, the speed. We are talking seconds. A gas leak happens and poof, in just moments you can have a massive flammable vapor cloud. If that cloud finds just one tiny spark, you've got a huge fire or worse, an explosion. That tiny, tiny window of time is exactly why we can't just rely on a person to react. It's just too fast.
So how in the world does a plant see a threat that's often totally invisible and has no smell? How does it catch it before it's too late? Well, it relies on this really sophisticated network of sensors. Think of them as the plant's own set of eyes and a super sensitive nose.
And this system isn't just a one-trick pony. It's on the lookout for three totally different kinds of danger. First up, you've got flammable gas. It measures this using something called the Lower Explosive Limit, or LEL. Basically, that's just a fancy way of saying how close is the air to going boom. Second, it's sniffing for toxic gases, measuring them in parts per million. We're talking concentrations so tiny they can hurt a person almost instantly. And finally, it's keeping an eye on the oxygen levels to make sure some other gas hasn't silently pushed out all the air we need to breathe.
Now, to do all that, it uses some pretty cool tech. You have point detectors, which are just like a nose sniffing the air in one specific spot. Then there are open path detectors. Think of these like an invisible laser tripwire, shining a beam of light across a big area, just waiting for a gas cloud to break it. And then you've got flame detectors. These things literally see the unique flicker of a fire, its special light signature. And they can spot it way, way faster than a regular old smoke detector ever could. Okay, so the second one of those detectors confirms a threat, the system doesn't just sit around and wait for a human to push a button. Nope, it triggers an immediate automatic reflex, a reflex that's designed to protect the entire plant and, more importantly, everyone inside it.
And this sequence, this automated reflex, is absolutely critical. Alarms are blaring, sure, but the system is already moving. It's kicking off an emergency shutdown, or ESD. And listen, this isn't just flipping a switch. We're talking about the system automatically slamming valves shut to cut off the fuel. It's starting what's called a blowdown to safely vent all that dangerous pressure. And at the same time, it's firing up the big guns, the suppression systems, like giant water deluge sprinklers or foam cannons, to start fighting the fire before it even gets a chance to grow.
So here's the bottom line, the most crucial point of all. This whole sequence is an independent layer of protection. It is designed to work all by itself without anyone touching anything. Trying to bypass it or, shut it down because you think it might be a false alarm, that is one of the single most dangerous things a person can do in a control room. You just have to let the system do its job, period.
So, if the whole system is automatic, you might be thinking, well, where does the human fit into all this? Great question. Because while that automated reflex is kicking into gear, the job of the control room operator suddenly becomes absolutely life or death critical.
What that operator does next, well, it's a stark choice between getting things under control and total catastrophe. The right way? You trust the system. You immediately start the emergency procedures and you communicate clearly with everyone. The wrong way, the path that leads to disaster, is all about hesitation. It's about deciding to go investigate by yourself, or just assuming it's another false alarm, or worst of all, hitting reset on the alarms without being 100% certain the area is safe.
And look, these systems, these procedures, they're not just theoretical stuff from a textbook. They are written based on the hard, painful lessons from real-world incidents where things went tragically, terribly wrong.
A lot of the time, the failure starts with something small. A detector gets covered up by accident during some maintenance work. A cable gets nicked. But one of the most dangerous failures, that's a human one. It's called alarm fatigue. Imagine you're an operator, and you hear these little alarms going off all day, every day, for nothing. Eventually, you just start to tune them out. And that's the moment of danger, because that's when a real alarm gets ignored, and this entire incredible safety system becomes completely useless.
Which brings us to the single most important, non-negotiable rule for anyone who works anywhere near these systems. This is the core takeaway of this entire explainer. You must assume every single alarm is real until you can prove without a shadow of a doubt that it isn't. Complacency is the real enemy here. That mindset, assuming it's real, that is what saves lives.
These fire and gas systems are really just one amazing example of the kind of invisible engineering that keeps our modern world running safely, behind the scenes. It kind of makes you wonder, doesn't it? What other invisible guardians, what other last lines of defense are out there protecting us every single day, and we don't even know they exist?